Hey everybody, this is Larry. This is day 8 of the what do we call it? November Leetcode Day Challenge, and there'll be a week 2 challenge later. Hit the like button, hit the subscribe button, join me on Discord, let me know what you think about today's farm. And today we have a hard one. So yay! Today I slept a lot today and I feel a lot better now. Now I can even walk around. My leg's no longer that sore, so I'm gonna go for a light run tomorrow. But honestly, right now, my main focus is to start packing for my trip. Also cleaning my apartment a little bit. I've had the excuse for the last few months of like, I have no energy to clean my apartment. I mean, I clean a little bit, but not like, wait until after the meltdown and this is it, right? So, in any case, yeah. So again, yeah, let's do this. Let's take a look at today's problem. We have 1611, minimum 1-bit operations to make integer 0. Given an integer n, you must transform into 0 using for operation any number of times. Change the rightmost 0 bit. Okay. The 0 bit. Okay, yeah. Change the ith bit. So one of the thing changed. What? Change the ith bit. Change the ith bit of the binary representation of n if the I minus 1 bit is set to 1 and I minus 2 through 0 bit are 0, right? So, wait, I mean, I think the operation 1 is straightforward, right? I don't have to explain it. We just change it from either 0 to 1 or 1 to 0, maybe. And then the other one is the I bit. Change the I bit if there's a 1. So if there's something like this, we can change x. I think that's what it's saying. Right? Is it what it's saying? And I'm about to change it to 0. Okay. I minus 1 bit is 1. Yeah, I mean, I think this is right. Do we change it from 1 to 0 or 1? Okay. I think the way to think about these things is to start playing with it. And then the other thing, of course, is that don't limit yourself by going this in one direction. Always think about the other direction. And what I mean by that is just that, what I mean by that is that you're going forward in the sense that that's what they tell you. Go from n, go to 0. Always think of the other way as well as you think about these going from 0 to n, for example, but in some reverse manner, right? Okay, so I guess the idea here is that, okay, let's say you have something like this, then now you convert this to a 0, okay? And then now what? Well, now what is that, well, you go back to here, and then now you change this to 1, because you can from operation 1. And then now, because this is 1, then now you could change this to 1, right? But from operation 2. And then now, because of that, you can do something like, what can you do? Change this to 0, and then change this. Okay, and you change that to 0, and then now you can change this to 1, right? And then now you can change the 0 back to 1 from here, and then now you do this thing where because or this is 1 with zeros behind it, you change this one to 0. So then change this one to 0, and then you do this, and then now a few operations later you're like this, right? And then now, I assume in some operations, then now you do something like this, right? And then after some more operations, you get to this. Maybe I'll add a dot 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 to be clear. And then now, because of this suffix, now you can change this one to a 0. So then now you got a little bit smaller, right? So then you did all that so that you move this to here. And then you have to figure out how many operation it is to move from one to right? From one of the ones to one of the zeros. And I think once you figure out the pattern and then you can sum it up, it should be fine. I think one observation here though is that and maybe it comes from here, right? Going from this one to here, you can kind of see that it takes 4 steps, but maybe another way to put it is that if you look at just the last 2 digits of here, right? What do you see? What you see is that you have every combination of the ones and zeros, right? On the last, only the last 2 digits. And as a result, that means that it takes 4 steps. That's basically what it means. You could probably do a little bit more, and I think and maybe if you're still not convinced, and I don't know that I am, to be honest, so there's no shame in that, is that I would maybe just write another thing, right? Like maybe expand this out a little bit more. You can also, depends on how it helps you, you could also simulate this 1 step at a time, because I suspect that this is going to take a long, 10 to the 9 is going to be too big, but you can write a basic simulation to kind of figure that out, right? So then now you just focused on the last 3 digit, right? Then now you can do, but here you can see that going from 0, 0, don't we have a 0, 0? Oh no, I guess this is just on this bit. Okay, so then now, you have a 0, 1, and then, so then now you have 1, 1. Did I do this one wrong? Oh no, I guess this is just how it looks like. It really looks awkward. But yeah, but in any case, then now you convert this to 0, right? And then now you can convert this to this bit to 0, right? And then now wait, no, that's not what you want though. I mean, you can do it, but it's not what you want, because you want to move to at changing this. So actually at here, did I do this wrong? No. Okay, I'm just being dumb. I see. I got confused a little bit on the operations, because then here the next step is that you just actually, this is the next step, right? Oh well, sorry, this is the next step. That's the idea of having the suffix. And then now you, in a recursive way, then now you flip this bit, right? And to flip this bit, you need to flip these 2 bits, and so forth. And then now, and yeah, right? So then now if you write it this way, oops. Right? And this is almost like symmetry, right? You're doing basically the opposite of going back up, right? Because you're trying to get to zeros. Right? Because literally, if you look at it like in a mirror kind of way, just the last 3 digits, it is a symmetric thing, right? Because then now you're trying to go to 110, and then now that will allow you to go to 10, and oh, I don't know why there's a 0, but the reason why this is symmetric is because then now this is the path all the way to here, right? And because of symmetry, you just multiply by 2, and that maybe is a proof that one of these operations takes power of 2 times, right? If that makes sense. Yeah, because that now it takes reverse operations to get back to here, right? And then now with the result being that when everything is done, you have to right? Okay, so there's dot here with the mirroring, right? Because then that is the equivalent of basically going all the way back to here where you follow all these steps, right? And then now you do it again to go to, oh, I guess this is actually where my dot is, and then so forth. And then now you move it 1, right? Okay. Okay. So we have an idea So, and we have some stuff. So how many operations will it take, right? So, okay. So I think it is clear that if you have something that looks like this, then now to change this bit, you need to convert, or well, to change this bit, you need to convert this to or to, how do I say this? So let's say you want to get, you want to get from let's say you want to get from here to I like to do it vertically because it's here, right? Well, that means that because you want to get to here, but before that you have to get to here. But that means that you have to convert all this to ones and then zeros, and that would take, by definition, all the 2 to the powers of, I guess, 4 in this case, right? I mean, I may be off by off by 1 in the power of 2s, but I think that's roughly right. Okay, so then now I think we have a little bit of now we have an idea on how the pattern works out. Then now what? Then now let's say we have a number. I mean, the examples are kind of crap, but let's say we have a more random looking number. Let's say something like this, right? What is the like? I guess the way that I'm thinking about it now, right, is that there are 2 ways about how we want to think about it, right? Like, do we? I guess if we're given this number, first of all, we have to get zeros for the we have to get all zeros here, and then that just becomes like, if you say it that way, then it's just a recursive problem, right? Okay, and then now that means that to remove, that means to do this, you have to do this, but divided by 2, right? Yeah. Do I have to do it recursively? I don't know. But I guess it is. But I think I'm looking at it from here first. But I think we can actually just look at it the other way, right? Maybe. Because then now, let's say we have this number. Then now we can calculate the number of operations to go to here, right? And then now that we're here, we can easily calculate the number of operations to go to the other minimum here, right? Because that means that everything to the right is going to be some 2 to the power of whatever. And then we remove this one, and then this one, and then this one, and then this one, and we should be good, right? In theory. Yeah. I think that's the better way of thinking about it. Yeah. This is annoying as hell though. But I think that's fine. Okay, let's try it out for actually the input. Okay, so maybe that's not interesting though. For 11U1, then we only take 1 operation to go to here, and then now it takes. Oh no, I lied. I mean, well, that means my strategy isn't working though. But well, I do want it, so I should not do least significant digit at a time. That's not quite right. So that's not precise actually. So what I wanted to, because my strategy or my thought process was that we take the least significant bit and then we just chop it off kind of thing, right? And then calculate it. But that's not quite right, because you need this bit to remove the bigger bits, right? Because the point is not to convert this to 0. The point is that now we have this, then we could convert this to 0. So maybe we have to do it from the most significant, because there are really only 2 ways to think about it. Or not only 2 ways, but 2 ways that I'm thinking about it anyway, is that you look at the least significant bit first and then solve your way to the most significant bits, but also maybe the other way around. So that means that for here, we're trying to figure out how to get to here. Because only in here, then now you can get to here, right? Which is what you need. But that also means that, yeah. But okay, so maybe this is a bad example. What if there's a 0 here, right? Well, if there's a 0 here, then we're trying to figure out how to get to, well, this, right? So then we can move this. So maybe it is just based on the most significant bit, right? Because then now we're trying to get to here. But then now we have to solve for this, which means that for here, to get to here, we have to get to here. Which means we have to get to here. Right? Let's just dot it. Right? Because that part I think we're okay. But then how do you get from here to here? Right? I think the first thing that I did not do, well, there are a lot of things I didn't do, but one of the things that I think maybe is important that I didn't do is find and figure out how to do, or what is the invariant of this problem. I think an invariant is actually you always want at least 2 1s. Because with 1 1, then now you can, quote unquote, move it to the left, right? And now you can move it to the left. This is kind of a messy problem. I mean, I don't think it is hard with enough time. And I am taking enough time. But it's just like so annoying. Everything is annoying. Give me a second. I forgot to post this. So if you're watching it now, you know, go to my Instagram page, because I just posted a new photo, the one of me hiking, in preparation for my trip. So give me some love, give me some support. I don't do ads, I don't do anything. I mean, unless you just count that as ads. I don't really do anything, but so like for fun, I do photography. So definitely check that out. Give me some likes, show me some support. It's not even a huge deal, but I just like seeing likes. I don't know. Maybe I am a little bit vain. I don't expect to make money off it. It's just nice to see people like it. But anyway, okay. This is kind of annoying. I mean, like, I feel like the idea we have is right, but, or at least for one bit at a time, but I think I was a little bit too optimistic about, like, solving this. Okay, so maybe we do try to solve it first, right? So then how we, right? So let's say we have this, then what do we want to do first? Well, in this case, because this is actually like a little bit weird, right? Because for this case, what we actually want to do is actually convert this to 0. So then we can convert this to 0. No, do we? Right? And then now we can move this one down, move this one down, and then now this. And then now we move this one down, this one down, this one down, this down, 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 right? I think maybe the first one is a little bit, okay. I think the initial state is interesting. That's the part that I think, yeah. Because I think once you set it up, I think here, the key thing is noting that maybe, oh no, okay. I was going to say that I could just, noticing 2 1s in a row, just convert this to 0, but I can't do that because everything in the suffix has to be 0, right? So we still have to do, okay, but what if, what if the first one looks something like this? What if there's a 0 in between? Then now, okay, we get 0. We have this 1. Do I try to? So I guess my question is, do I see. Because I guess that's the trouble that I'm having trouble with, is that for here, do I go to here? Whoops. Do I go to here and then move this to the right? Or do I, make this one and then convert these to 0 immediately, right? I think that's the part, because then now, that means that if you can move this one to the left, then now you can, remove this, and then now you have this, then now I think that's where I was like, maybe there's an error, because does it make more sense to convert this to here, to go here? Because then now you're here, then now you can move this one to the right and then get rid of it, right? Is that the same? Are they different? Like, do I have to do both? Like, or does the path go through both? Maybe that's the part that I'm confused about. I think maybe it's worth trying some examples then. Okay. So then now if we have 1, 1, then it takes 1 operation, and then now it takes 2. Because the way that I write it, right, it's that if we have 1, 1, which is an example, I would actually remove the 1 first, and then now we have this, it takes 2 more moves, right, which is to go to 1, 1, and then now 2 moves to move the 1 to the 0, and then now which is obviously way more moves, right? Why is this such a struggle? Right. Because the obvious move is that you go, well, this one, right? And that, I guess that this is why it's fun beyond for all these things about like here. Do we actually want to move the 1 to here? Like, is the next move to go here? But then like, but then now it is so that you get this to 0, and then maybe, but maybe the better move is to, now that you have here, then now you go here instead, which allows you to do this maybe. Man, why am I struggling so much with this one? I feel like I'm missing. I think that's the thing, right? Is that when you don't, sometimes like you're missing some key component, it will make this problem much trickier. I think the power of the 2 per move thing, I think I think that part is fine, but okay, let's see 6, right? Or maybe I could do maybe this is what I'll do. I'm going to do a breadth first search thing. I know that you can't go to 10 to the 9, but at least maybe to get myself a pattern. I think that's the part that maybe I'm still misunderstanding a little bit. Okay, so let's say we're right? Because this now reminds me a little bit of what's that called? The Boolean subsequence or something? The Boolean or sequence, not subsequence, right? But don't know why I remember that, to be honest. Okay, so then now you can go to here, right? Oh, well, technically you go here and then here. Is this right? What? When we get to 1,000, wait, is this right? No, this is something went wrong. That's why this is wrong. You can't go. You can't just turn it off. What you want is on 1, and then now you do what I said about mirroring, right? And then now you mirror this again. Because one way to think about it is that, okay, for the first bit, you can see that they mirror, right? And then now, if you just look at the second bit, then now this mirrors this, right? And then now that means that if you kind of think about this, then now you take this and then mirror it, you would get the same thing because you're just going in backwards to get to the just with a 1, right? So if you kind of ignore the prefix, then now all of these is going to be same thing as these, but with the 1 backwards, right? But this is like a ridiculous. I mean, I could, just to be clear, like I think I can solve this on this alone, but it is like I feel like there should be an easier solution, is what I mean, right? And all I'm doing is quote unquote mirroring, right? What I mean by that is that if you look at this, the last 3 digit here is the same as the last 3 digit. This is here, this is here, this is here, right? And the reason is because we're going from 100 to 0 and 0 to 100, right? And then you could kind of like, from this, you can think, well, okay, then now what? Then now the next stop is also mirroring, right? And then now you mirror, you take all this and then you mirror it out, right? And from that, you could get a pattern to figure out the shortest path to the end. But, and as I said, you can certainly solve this just by this factoid alone. And I certainly have, and doing like hardcore contests in which I don't know any better, and I maybe still today do not know any better. That's all I need. But I'm trying to figure out, like, is there like a better pattern that I'm thinking of, right? And maybe there isn't. I don't know. Like, okay, let's say we do have this idea, right? Then what does that mean? That means that if we have something like this as the input, or maybe not this one. Right? And you could do this like recursively to find out the position and stuff like that. Maybe it's fine. But then now you have something like this, then what's the idea? The idea is that, okay, if this bit is odd, then you do a recursive thing where this is you mirror this to 0, right? And then you go again or something. I don't know. This is so weird. I hope you are following so far. I mean, like, you know. But okay, so for example, but this is because we're trying to get all this all the way to 0. So then now, so the farthest between 2 points is going to be a 1 and a 0, and you could do it in both directions, right? Because if this is a 1, you're trying to get it to a 0. So then now, after a lot of things, you're going to do, right? That's basically it, with this being mirrored. So in effect, it takes that many moves to get from here to here, right? But okay, so that does not answer my question yet, though. Let's say, okay. Let's say we have 101, 100, right? Let's just ignore the prefix for no, we can't. Let's just say we have this thing, right? And now, how do we solve it? Well, we just look up here and we know that it's going to go here, right? And this one, the strategy suggests is that, well, these two ones, we want to get rid of this one, and then we slowly go to the back, right? But what if we have a 1 here? If we have a 1 here, then okay, so dot, right? Oh, technically, actually, this is just immediately the next one. But then now you have to do a lot of moves to go to here, right? And then this will, in turn, oh, actually, I guess this is the next move is here. So that means that this number resolves with is inside here somewhere, right? Because everything else has a bigger number, so that means that we're looking for this number is inside here and the dot, this dot, and as a result, that means that the next number, if we're here, we want to get to is actually here, right? So this is the number that we want to go to next, and not. Okay. And then I think this is the idea that we can play along with. And here, to get to here, wait, did I do that right? Oh, no, this is right. And then to get to here, I guess this is where the mirroring comes from, but I didn't draw all the mirroring because that's like a lot of numbers. Well, that means that we have 1101 trying to get to 00, right? That's basically it. But how do we? So I guess that's still the thing, is that I guess it depends on what, because 1101. Then now we're trying to get to here, and then yeah, and then it just goes down, right? This is a very annoying one. So that means that if we have a really big number like we did earlier, oh, got it. I think I actually even did mirroring here, but I wasn't as explicit about it in terms of finding an example. But okay, so I think I agree that, you know, if we're here, we're trying to go here next because that's the shorter direction. But then how do you calculate how many moves it takes from here to here, right? Like, what are the more intermediate moves, right? The more intermediate moves is that we are trying to get to, oh yeah, and all these numbers in between has a 1111 prefix, so then it's just dot, right? And we're trying to get to 0. So that means that these all have numbers, and to get all these to 0, it means that previously we have this, right? That means that before that we, which allow us to go from do, but also before that, that means that we're trying to get to right? Wait, is that right? Here, okay. I mean, I think this is closer, but so here makes sense. Here to, okay, I guess maybe it still makes sense. It's the same logic. Okay. I think I just messed up somewhere though. Because now I'm heading toward this way, which is not what we want to do, right? This is a 0. It is not, okay, I lied. I think this is where I'm more. It is not true that everything before this has a 1 as a prefix by definition, because for example, the one before that, this would be this. So it doesn't, so I'm not even, so, okay. So that means that we still, this part is still true, but what are the intermediate steps? Well, right before this, you need this. I guess that's what I was saying. And then we have this. This still makes sense to me just because you can do 101, right? Like But you don't want to do this. You want to, because that's the wrong direction. Here we actually want, so this may not even be the right direction. The right direction may actually be this. And then now do. Right? So this is the right direction. Right? So then what does this mean? But keep in mind that in this case, we do not want to go, like this is the wrong direction. Maybe the way to think about this is too hard for me. Maybe the way to think about it is what I said about just using the pattern and doing it recursively. Listen, look, if you're watching so far, my apologies, but also, you know, this is live and this is, you know, part of this is how you're supposed to grind out a problem. Not every problem is going to be pretty and be like, oh yeah, it's just this. And even though I knew the power of 2 stuff like very quickly, this is still a chore, as you can see, right? But yeah, I think I'm going to do the mirroring pattern thing, right? Because once you have the mirroring pattern, then maybe you can figure it out a little bit, right? Because this mirrors all the way out to here. No, this is the next number. This is not the mirror. This is the mirror. But another way to think about it with respect to the mirror is that this number how do I say this? This number is perfectly like 2 to the power of whatever before, right? Because it has every other possible number. So, okay. So let's say we have something like this, then what does that mean? That means that this is the last number that we actually get with that many digits, right? I see. Okay. I think I know what I want to do. I think I was still stuck on... even though I said it this way early in the video, I said that I wanted to convert n to 0. But what I actually want to do is just construct the number maybe 1 bit at a time from 0 to n. But I have to do a little bit of like negative math or something. Because, for example, if I have this, maybe the way that I'm tempted to do is that, okay, now we try to get to here. But that's not true. But this is actually the last number with this many digits, right? So that means that we have to subtract out how to get to here. And then subtract, and then in like a inclusion exclusion kind of way, from here what do we want to care about this, which is the last number here. So then we subtract out this thing. So I think this maybe have a easy formula. It's just about this subtracting this, like almost like a recursively, like subtracting this kind of thing, right? Because this, now we subtract the suffix, but we overcount it because now we have to subtract it from here and so forth, right? Maybe, I don't know. I'm gonna try it just because but before we do, we should try it on example first, right? Then here we have 11, which means that we're trying to get to 10, but then we want to subtract out 1, right? So that means that for 10, as we said, how many moves is there to 10? From 10, we go to 11 to 0, 1 to 0, 0. So that's 3 moves. Is it 3 moves? I thought it would be 4 moves actually. No, it's 2. It's a power of 2 to move from 1 to 0. So to go from 1 to 0 would be 2 to the summation of 1 plus 2 plus 4 plus 8. So the power of 2 minus 1. Okay, that's fair. And then now, because this is 3 moves, then now we will subtract out the 1 move. So that's going to be 2. So that passes that test. Okay. And then now we have 6. So 110. 110. We want to say, okay, so we start at 100. So that's... what did I say? Was it going to be 1 plus 2 plus 4? So that's 7, right? That's going to be 7 moves. Subtract out 10, which we already know it's going to be 2 moves. So this is going to, which doesn't really work because in this case I would say it's 5, but it's obviously not, right? Because it's 4. Unless I'm off by 1 on this one. Why? Okay, let me just take a look. All right, so we have 110. The next move will be, well, just 0, 1, see, do it, right? And then now this. Why is this 4? Oh, no, this is 4. This is right. Because then now you do, right? And that is 4 moves. Now, why is this 4? Because I want to subtract out the 2. Is this not 2 moves? Oh, no, 10 is not 2. That's why. I looked at this and I saw 2, but it is actually 3. Okay. Well, I mean, that still works if that's the case. So, yeah, maybe we can do it that way then. I don't know. I mean, I think I mean, this is so hard. At least for me. Maybe if I'm more practiced. But, okay. That means that we want to say... How do I want to represent this? I mean, n is dirty, right? Or number of bits is dirty. So I'm not... you could do this in... quote unquote linear or dirty, but I'm going to do it with dirty square. So then we just go right? So let's just go of or let's say f of x, right? F of n. And what I'm going to do is just get the most significant bit. Yeah, and then for I in if this is the case, then we want to say yeah, and also if it's total, I guess if x is equal to 0 is 0, then we turn 0. Otherwise, then now we want to say it is going to be return 2 to the power of, let me write it out for 2 to the power of, is it I or I minus 1? So if this is 0, 1, 2, it's going to be 3. So it's actually 2 to the power of I plus 1. Yeah, maybe. Minus 1. Plus f of x with this bit flip, right? So the suffix of this. And yeah. Alright, that did not work. I mean, I think my math is, I mean, maybe my implementation's wrong, but then my math should be right. So we could print it out real quick. Oh. Well, if this is not 0, then this should always exist. So I think that's fine. Also, it would return none if this is an error. But, how would I print this? In an easy way. Alright, I just print it here. This is not quite the cleanest, but that's fine. 1 is 1, that's true. 11, what did I say 11 is? 11 I said is, oh no, this is not an add, this is subtract, okay. I mean, I know we actually did talk about this. Okay, okay, so it's just me somehow having 5 lines of code and still having the wrong implementation, but okay, that's fine. Alright, I guess we should, I mean, during a contest you can do this, I mean, you can, but it just won't give you an answer that you understand. But here we can choose, you know, see if that works for a big number. If it works for 1 million, I think we're probably fine, honestly. I'll try another big number just for sakes. Looks okay, give it a quick submit. 2048. You know, I don't know if they planted this, but you know, having a power of 2 on a problem like this today is definitely a choice. And of course, getting the most significant bit, you can actually just keep on getting the most significant bit. So you could do this in linear time, linear being over b, where b is the number of bits, which is at most 31. My implementation is actually b squared. You could think of this as 2 loops, really. But I'm, you know, when b is 32, I'm not going to overthink this. I just want, well, also to be sure, I wasn't sure that this is clear. I am going to explain this a little bit because I think I jumped a little bit at the end because I think I finally saw it, but it took a long time, as you saw. It took almost an hour, really, 48 minutes. I think the key idea here is to, and this is why I drew it out so much. I think the key idea for me, and it took a long time, is that the 2 parts. One is this like going from 0 back up, even though I mentioned it. I finally kind of drew it out, as you saw. Yeah, as you saw, I drew it out from 0 all the way back up. So that's the a thing that we could see the visualization. And then the other thing is that what I tried to do instead, because I think I was trying to build them up in an additive way, right? And what I mean by that is that, let's say we're trying to get from here to here, or somewhere in the middle, maybe even. What I was trying to figure out how to do, and maybe we still do this, to be honest, but I just kind of I just couldn't figure it out. Yeah, maybe, and yeah, you definitely could do this, maybe, but I couldn't figure it out, as you saw. Is that I try to build this in an additive way, and what I mean by that is that I'm trying to get from here to some point inside here. I would go from here to adding, I don't know, here to maybe add here, and then the sum of those components would give me the answer. That's what I was trying to figure out how to do. But as soon as I saw it this way, and this is why, I mean, I know that at that point I didn't explain it that well when I was doing it live, because I wasn't 100% on it. That's the real reason. Like if I had more confidence about it, I would have slowed it down and brought more detail. But at a certain point, I'm like, I don't think I actually know how to do this. I thought I did, but I didn't, right? So I have to try something new, and as a result, I didn't want to spend too much time explaining the wrong thing. But what happened here is that I was like, okay, well, actually, as you see here, this is actually the one with all the zeros at the end. That's actually not the first number or the middle number or whatever in the thing, right? The one with all the zeros is actually the last number in the sequence, right? Or last number in the sequence with that number of digits. For example, 100 is the biggest number in the prefix. 1000 is the biggest number here, right? And so forth. And then as a result, I thought, well, in that case, that means that this is the biggest number, and that means that everything in between is the smallest, like it's going to be inside it. And then as a result, I just go, okay, well, if this is the case, then now, like, in a way, you just subtract out the components, right? For example, if you're here, then now we just have to subtract out how to get to, if let's say we're trying to figure out here, right? If we're trying to figure out here, that means that we just have to try to figure out, okay, well, the suffix is 0, 1, 0. So that means that we have to try to figure out how to remove this, because we know that, and some part of this is this mirroring idea, right? Because I know that from here to here, right, it's going to be the same distance from, let me draw some out. From here, oh, sorry, maybe the other way. If we're trying to go to here, from here to here, it's the same distance is from here to here, right? I think I drew it in the wrong place, but you get the idea, right? So I knew that so that's how I kind of figured this out, is that I was like, okay, well, we know that this is the biggest, there's some numbers in between, but from here to here, it's going to be the same from here to here, but without the 0. I mean, it is mirrored, so it's going in the opposite direction, but because it's mirrored, the distance, which is what we care about, is the same. This one is a little bit of a bad example, per se, because it doesn't have that many ones, but then that's where I got the recursive thing of, is that, okay, now we go, okay, well, in a recursive way, if we're trying to get from here to here, then what does that mean? Well, we don't have enough ones to show you, but that means in a recursive way, then now we're just trying to find the suffix, right? Because here we have 1, and then we look at the suffix to the right side of the 1 to kind of recursively figure out that way. And that's kind of how I solved it with, this is the idea here, right? And that's it. He said, as it took like an hour, as if it was easy. Solved it, I don't know. I mean, I have previous videos. I don't know how I did this, honestly. This looks crazy to me. Hopefully if you watch that video, maybe past Larry explained it a little bit better. I guess this one actually is probably like a good, gray code is the number what I was looking for. I mean, the Boolean thing is also the same thing, but gray code is also like a similar idea, which is what I said of like it from here to here goes through every possible suffix, and then change the first. I guess the way that I did it here is more algorithmic, and I have 2 functions here. And I did this recursively as well, but man, I don't know how what is this? Who wrote this? I don't know how that came out, to be honest. I don't remember. And then this is from 2 years ago now. I guess I did this almost the same way, maybe. Yeah, I mean, this is basically the same idea. I mean, I wrote it differently, and this is the linear way of doing it, because you only do the for loop once and not recursive. And you just, because this is the inclusion-exclusion idea as well. Because you're subtracting one, but then you overcompensate, so you have to subtract it for the suffix and so forth. And I think that's what I did here too. I guess I noticed the mirror thing in the previous attempt. Maybe I don't know what language I used, but in terms of how I said it, but that's the idea. Okay. This is a very long video. Hopefully this makes sense. If you skip to the end, like now, the last 10 minutes or so, I try to explain it. So hope that's okay. I don't think this is easy or trivial or even understandable at all. So let me know what you think in the comments. Let me know how you did. And yeah, that's all I have for this one. This is the way I did is quadratic. This is more linear, though somehow it's slower, but this is the same code, right? This is the same thing as this. And the sign is just because we alternate on the every other one, because when you subtract, you alternate. It's also an idea about like inclusion exclusion type thing. But yeah, that's all I have for this one. Let me know what you think. Thanks for watching. Yeah, here's a very hard one. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.